Engineering and economics are two disciplines that have a long and intertwined history. Engineering is the application of physical science and mathematics to solve practical problems and create useful products or processes. Economics is the social science that studies how people make choices and allocate scarce resources to satisfy their wants and needs. The linkage between engineering and economics can be seen from different perspectives. One perspective is that engineering is a driver of economic growth and development. Engineers design and innovate new technologies that improve productivity, efficiency, quality, and sustainability of various sectors of the economy, such as manufacturing, transportation, energy, communication, healthcare, and agriculture. By creating new products or processes that meet the demand of consumers or businesses, engineers contribute to the creation of value, wealth, and welfare in society. Another perspective is that economics is a tool for engineering decision-making. Engineers often face trade-offs and constraints when designing or selecting among alternative solutions. They need to consider not only the technical feasibility and performance of their solutions, but also the economic viability and impact. Economics provides engineers with methods and models to analyze the costs and benefits of different options, taking into account factors such as time, risk, uncertainty, opportunity cost, depreciation, inflation, interest rates, taxes, regulations, market conditions, social preferences, and environmental effects. By applying economic principles and techniques, engineers can optimize their solutions and maximize their value. A third perspective is that engineering and economics are complementary disciplines that share a common goal of improving human well-being. Engineers and economists both use scientific methods and logical reasoning to address complex problems that involve human behavior and interactions. They both rely on data, evidence, experiments, models, simulations, and optimization to test hypotheses and evaluate outcomes. They both aim to find solutions that are efficient, effective, equitable, ethical, and sustainable. By collaborating and communicating with each other, engineers and economists can learn from each other's perspectives and insights, and create better solutions for society. In conclusion, engineering and economics are closely related disciplines that have influenced each other throughout history. They have a mutual dependence and benefit from each other's contributions. The linkage between engineering and economics is essential for solving the challenges posed by the modern society that is increasingly influenced by technological innovations. Engineering economics is a branch of economics that deals with the analysis and evaluation of engineering alternatives in terms of their costs and benefits. Engineering economics helps engineers to compare different options and choose the best one that maximizes the value or minimizes the cost of a project, product, or process. Some of the main concepts and techniques of engineering economics are: time value of money. This concept recognizes that money has different values at different points in time, due to factors such as inflation, interest rates, and opportunity costs. Engineering economics uses various methods to calculate the present value or future value of money, such as discounting, compounding, annuities, and perpetuities. These methods help engineers to compare cash flows that occur at different times and adjust them to a common basis. Cost estimation. This technique involves estimating the total cost of an engineering alternative, including both fixed and variable costs, direct and indirect costs, sunk costs and opportunity costs, and relevant and irrelevant costs. Engineering economics uses various methods to estimate costs, such as historical data, parametric models, learning curves, and expert opinions. These methods help engineers to forecast the expenses and revenues associated with an engineering alternative. Benefit cost analysis. This technique involves comparing the benefits and costs of an engineering alternative, using a common measure such as net present value, NPV, internal rate of return, IRR, benefit cost ratio, BCR, or payback period, PP. Engineering economics uses various criteria to select the best alternative, such as maximizing NPV, maximizing IRR, maximizing BCR, or minimizing PP. These criteria help engineers to measure the profitability and feasibility of an engineering alternative. Risk and uncertainty analysis. This technique involves assessing the variability and unpredictability of the outcomes of an engineering alternative, due to factors such as market fluctuations, technological changes, environmental impacts, and human errors. Engineering economics uses various methods to analyze risk and uncertainty, such as probability distributions, expected value, standard deviation, coefficient of variation, sensitivity analysis, scenario analysis, decision trees, and simulation. These methods help engineers to quantify and mitigate the risk and uncertainty associated with an engineering alternative. Some examples of engineering economics applications are: designing a new product or process. Engineering economics can help engineers to estimate the development cost, production cost, market demand, selling price, profit margin, break-even point, and return on investment of a new product or process. Selecting among alternative projects. Engineering economics can help engineers to compare the present value or future value of the cash flows, net benefits or net costs, profitability or feasibility indices, and risk or uncertainty factors of different projects. Evaluating an existing system or operation. Engineering economics can help engineers to measure the performance efficiency, operational effectiveness, maintenance cost, depreciation rate, salvage value, and replacement cost of an existing system or operation. Engineering economics is a practical and useful discipline that helps engineers and managers to make better decisions in various engineering contexts. Engineering economics can be applied to different industries, such as manufacturing, construction, transportation, energy, communication, healthcare, and agriculture. Engineering economics can also be used for different purposes, such as designing new products or processes, selecting among alternative projects, evaluating existing systems or operations, and improving performance efficiency and effectiveness. Some real-life facts and industrial applications of engineering economics are: according to a survey by the American Society for Engineering Education, ASEE, engineering economics is one of the most common topics taught in undergraduate engineering curricula in the US, with 87% of engineering programs requiring at least one course in engineering economics. Engineering economics can help engineers to design new products or processes that meet the market demand and customer preferences, while minimizing the development cost and maximizing the profit margin. For example, engineering economics can help engineers to determine the optimal size, shape, color, material, and features of a new product, such as a smartphone or a car. Engineering economics can help engineers to select among alternative projects that have different costs, benefits, risks, and uncertainties. For example, engineering economics can help engineers to choose the best location, design, and construction method for a new bridge or a power plant, based on the present value or future value of the cash flows, net benefits or net costs, profitability or feasibility indices, and risk or uncertainty factors of each project. Engineering economics can help engineers to evaluate existing systems or operations and identify areas for improvement or replacement. For example, engineering economics can help engineers to measure the performance efficiency and operational effectiveness of a manufacturing system or a transportation network, and calculate the maintenance cost, depreciation rate, salvage value, and replacement cost of each component or asset. Engineering economics can help engineers to improve performance efficiency and effectiveness by applying various methods and techniques, such as value engineering, forecasting, cost estimation and analysis, decision-making under different environments, risk and uncertainty analysis, project management, scheduling, and optimization. These methods and techniques can help engineers to reduce waste, increase productivity, enhance quality, save time, lower cost, increase revenue, and achieve sustainability.